Hey, welcome back. This is the second section on slope and linear functions. 2.4, we're going to talk about some of the more interesting parts of slope, I guess, if you will, a little more technical and helps us get to other things. Specifically, this section we're going to be talking about finding the slope and equation of parallel lines and also perpendicular lines, lines that are parallel to one another and perpendicular to one another. And we're going to talk about the slope as a rate of change and then be able to find the function's average rate of change. And that's true for any function, not just linear functions, but it is in kind of a application of slope, if you will. Okay. So for parallel lines, two non-vertical lines are parallel if they have the same slope. And if they're parallel, they have the same slope. That's an if and only if statement. All right, so lines that have the same slope are parallel. And if two lines are said to be parallel, they have the same slope. If they are both vertical, means they have undefined slopes, then they're also parallel. So undefined can't be equal to undefined, but if they're both undefined, we can say that they're both vertical lines and therefore they're also parallel. Okay, so parallel and same slope, that's what 1 and 2 say together, is that those mean the same thing. All right, so if you're given a line, y equals 3x plus 1, and then we want to find the equation of a different line, right, that passes through here. So just as a picture of what's going on, just real basic sketch here, you've got the line 3x plus 1, which has a y-intercept of 1 and a slope of 3, right? So you go up 1, 2, 3 and over 1, and that gives me the 0.14, and then you connect those dots. All right. Connect those dots. There's your straight line. Put arrows on the end of that. And this is the line you're given. But then you want to find a line that's parallel and it goes through negative 2, 5. So negative 2, 5 is over here someplace. Negative 2 up 5. Right? So it's not on the line, obviously. We're looking for a different line who is parallel. Right? Who is parallel to the black line. Okay, and so that's what we're trying to find. So how do we do that? The first thing we do is find the slope of our line. Well, our line is in y equals mx plus b form, and so the slope of that line is equal to the number in front of the x. It's just 3. So the slope is 3. And now we use that slope and our new point, negative 2, 5, to find the equation in point slope form. And so you get y minus 5 equals 3 times x minus negative 2. We don't typically leave it that way, right? Usually we would write this as y minus 5 equals 3 times x plus 2. That's point slope form. But then, of course, you can go beyond that. And this is perfectly fine. This is what they asked for, right? In point slope form. Make sure when you're doing MyMathLab, you read the directions. That's point slope form. But then if you wanted to solve it for y, this would kind of be step 3. We could put it in slope-intercept form, and now we get y minus 5 equals 3x plus 6, distribute the 3, add 5 to both sides. All right, and you get y equals 3x plus 11, and that is the equation for the purple line over here, which is parallel to our original line. So the key is that your original line has a slope of 3, and so you've got to use the slope of 3 and the new point. Okay, this line has nothing to do with anything except giving you the slope. So here's a second problem for you to do. As before, I'm going to pause the video, or you guys pause the video. I'm going to tell you to pause the video in just a second. Pause the video, come back to this spot if you need to, and get these written down, and then go to this problem. Here I want you to find the equation, an equation for the line passing through 7, negative 4, and parallel to this line. Notice that this line is not in y equals mx plus b form, so you got a little bit more work to do. All right, so step 1, find the slope. Step 2, write your equation in point slope form. You don't have to go any further than that. So hit pause, give it a shot. Okay? So, the new thing here is we've got to solve this first equation. We got to solve it for y in order to find the slope. So we're going to subtract 2x from both sides. We get 5y equals negative 2x plus 3. And then we divide everything by 5. And so we get y equals negative 2/5 x plus 3/5. So the slope of our given line is negative 2/5, which means our new line also has a slope of negative 2/5 because it's parallel to our line. And then the point we're going through is 7, negative 4. And so here's your m, here's your x1, y1. And so if we write this out, we get y minus y1 equals m times x minus x1. This is perfectly legitimate as your answer in point slope form. If I asked you to go further, step 3, and solve it for y, you'd get y plus 4 equals negative 2/5 x plus 14 over 5. Negative 2 times negative 7 is plus 14 divided by 5. And then you would subtract 4 from both sides. And when we subtract 4, remember that 4 over 1 is the same as 20 over 5. Right? So get a common denominator of 5, got to subtract 20 over 5, and so you get y equals negative 2/5 x minus 6 over 5. And that is the equation of your line in slope-intercept form. This is a perfectly good equation for your line in point-slope form. Okay? So that's the process. Hopefully that wasn't too crazy. Basically, the only new part here is the slope idea, right? Once you find the slope, given a slope and a point, this is stuff from section 3. So if I stop right here, this is section 2.3. If you're having trouble with anything below the line here, with this formula and below, then you're not really having a problem with section 2.4. You're having a section 2.3 problem, so you need to go back and review that a little bit better, or maybe practice that a little bit more, okay? So that's for parallel lines. When it comes to perpendicular lines, two non-vertical lines are perpendicular if the products of their slope is negative 1. And that goes both ways. Again, this is an if and only if statement, 1 and 2 together. And so another way to say that is that, as an example, if your slope is 2/3, then your perpendicular slope, this little upside down T represents perpendicular, your perpendicular slope is supposed to multiply to give you negative 1. Well, that means you need the opposite sign, and you need to do the reciprocal, because reciprocals multiply to give you 1. And so another way to write this is that perpendicular lines, if they're not vertical or horizontal, perpendicular lines have slopes that are negative reciprocals of one another. You flip over the number and you change the sign, and that's how you get the new slope. Okay? And obviously, if you have a horizontal line, it has 0 slope. Vertical lines have undefined slope, and those two are perpendicular to one another. Horizontal and vertical are perpendicular to each other. Okay? So, if you want to see how that works out, okay, well, we want to find the slope of a line that is perpendicular to the line whose equation is x plus 3y minus 12 equals 0. Well, the first thing, what do you have to do? You have to solve this for y so you can find your slope. So just like last time when I didn't have it solved for y, I need to solve for y, add 12 to both sides, subtract x from both sides, and then divide everything by 3, and you get negative 1/3 x plus 4. 12 divided by 4 is 3. And so that tells me that the slope of my line, the given line, right, this guy, his slope is negative 1/3. What does that mean about our perpendicular line, however? Perpendicular line, what's it supposed to be? Perpendicular line is supposed to be the reciprocal of this, so flip it over and change the sign. If you flip 1/3 over, you get 3 over 1, and then you change it from a negative to a positive, and so your perpendicular slope is 3. Your perpendicular slope is 3, okay? And then if you want to find the equation, you have to have a point and go on, right? So, but that's how you find the slope. So once again, you guys, here's an equation, same exact line, same exact point as you did last time, except that this time I want you to find a line who's perpendicular to the given line and passes through that point. Okay, so hit pause, find your stuff, go back in the previous video if you want to, earlier in the video I should say, but hit pause, see if you can solve this, and then we'll go over it together. Okay, so once again we need to solve for y, subtract 2x from both sides. You get 2x plus 3, divide everything by 5, right? And you get y equals negative 2/5 x plus 3/5. That means that the slope of my line is negative 2/5. The slope of the given line, I should say, is negative 2/5. What's the slope of the perpendicular line that you're looking for? Right, positive 5/2. Flip over the number, change the sign, and then you get the 0.7, negative 4. And so once again, we're going to do y minus y1 equals m times x minus x1. This is perfectly legit. Okay, this of course is y plus 4 instead. Distribute the 5/2, you get 5/2 x minus 35/2. If we subtract 4 from both sides, remember 4 over 1. This time over 2, that's the same thing as 8 over 2. We're subtracting, and so we get 5/2 x, y equals 5/2 x minus 43/2. When I subtract 4 here, I subtract 4 over 1, that's the same thing as 8 over 2. 35 and 8 is 43, both negative. And so this is your equation solved for y. This is your equation in point slope form, depending on how they ask for it. MyMathLab will ask for specifics. You need to know the terminology. If you put in the wrong form in the wrong place, I will not give you credit for it. Okay, you got to put in the correct form in the right place. Okay, so that's how we handle parallel lines and perpendicular lines. Again, most of the work really, after you find the slope, all of the work is from section 2.3, using the point slope formula and then solving for y. So that stuff you should be familiar with. Rates of change, I mentioned this before, but a rate of change, slope is just the way that y changes compared to x. It's how fast y is changing with respect to x. That's why slope of a line like this is a very small number, positive, while slope of a line that looks like this is a much larger number because there's much bigger change in y compared to x. All right, and so for linear functions, the slope can be interpreted as a rate of change. So here's an example. In 1990, 9 million adult men in the United States lived alone. In 2008, 14.7 million adult men in the United States lived alone. So we form word pairs. We use the year as our x value and the number of million of adult men living alone. Express the slope, right, to represent the rate of change of men per year. Okay, and so that's how we're figuring it out. And so we've got these two numbers. We're going to plug in, right, to your formula. M equals change in y over change in x. Right, that was 18 years, and that was 14.7 minus 9. Okay, I've got it worked out neater here on the next page. So if you plug those in, you get 5.7 over 18, and that's approximately, this is rounded off, 0.32. Now what does that mean? Well, you had, on top, you had what? Million of men, and on the bottom you had years. So the rate of increase is 0.32 million men per year, or the approximate rate of change is 0.32 million men per year. Okay, so about 1/3 of a million men per year increase in living alone over that 18-year period. Okay, So just being able to, I'm not going to ask you to do much more than that. I'm not going to ask you to create your own models. I am going to ask you to understand how your rate of change works. And again, the units are simple because the units on top divided by the units on the bottom give you the per. All right, so million on top, years on the bottom, million per year. That's how you come up with your units for rate of change. Okay. Also, if you want to find an average rate of change for any function, not just a linear function, but for any function, then remember this is like your y1 and this is like your y2, so it's just the slope formula. Change in y over change in x, you plug in and you figure it out. So for a function f of x equal to x cubed, if you want to find the average rate of change between x equal -2 and x equals 0, right, you want to find out the average rate of change, then you plug in 0 for x2 and -2 for x1. You plug them in. F of 0, 0 cubed is 0. All right. -2 cubed is -8, and 0 minus -2 is 2. And so you get an average rate of change of 4. Now, we don't have any units associated this time, but what does that mean? What does that look like? Let me give you a picture here of what's going on. So what's the graph look like here? Well, graph of x cubed, all right, you might not know that quite off the top of your head. We'll learn it soon. Graph of x cubed is an S shape. It comes up like this, turns flat, and goes up like that, sort of like that, okay? At -2, you're way down here. If you plug in -2, you get -8. If you plug in 0, you get 0. Now, if you connect the dots here, this straight line that goes through those 2 points, that straight line represents the average rate of change. Obviously, you're changing at different rates because of the curve, but your average rate of change is 4, and that's the slope of the blue line. Figure not to scale, obviously, but that's what average rate of change means. It is the slope of a line. So this is called a secant line. You'll learn that later in pre-calc and calculus, but a line that connects 2 points on a curve is called a secant line, and that slope is the average rate of change. Okay, so these are some calculus concepts that you'll need later on, just kind of introducing you to the idea while we get into more about slope. So this is an application of slope, and hopefully that clears things up. Again, if you're having any trouble with the problems we did today, make sure you understand where that problem is happening. And if you're having problems finding the equation of the line once you know your slope, you're having a problem with section 2.3, not 2.4. So go back and check that out. Okay, thanks. See you next time.